We're going to continue in section 6.4 today, talking about factoring trinomials. We're going to be using a different method than we used in the previous video. So section 6.2, I told you that I don't recommend using the help me solve this or view an example buttons on the math lab because the way I teach factoring trinomials is not the way your book teaches. Well, the same thing is true with section 6.4. I teach factoring trinomials in a different way than the book does it again, and this is a different type of trinomial. And so I need you to be aware of the two ways I'm going to show you, because these two ways will always work, and they're easier for the most part than trying to do a trial and error, guess and check, or any other method that you might see. So let me back up and point out something from the previous section. So you'll notice that when we factored trinomials, we did what we called reverse FOIL. And you'll notice that every one of these had a leading coefficient, this first number, as a 1. 1y squared and 1x squared, 1t squared, 1y squared. Even here, 1a squared, 1r squared, 1r squared, 1m squared. And then 1b squared, 1r squared. And then on these last two, there was a greatest common factor, in this case of 4x cubed, and when you took it out, you were left with x squared. Again, 1x squared. In the last one here, you had negative 3x squared as your common factor, and when you factored out, you had x squared. So again, 1x squared. And so when we factor trinomials where that leading coefficient is 1, we use reverse FOIL. When it's not 1, like it is in this case, and there's not a common factor to take out, or even if there is a common factor to take out, but you still have a leading coefficient of some number other than 1, then we're going to use a method that we're going to call bottoms up. Now, the really key thing to using bottoms up is to know when to use it. So you're going to use bottoms up when your leading coefficient is not 1. Again, that's this number where the 3 is. And you're factoring a trinomial. Okay, this doesn't work if it's a binomial or if it's got 4 terms. It only works if it's a trinomial. So that's the key. Trinomial and leading coefficient not 1. Okay, so as we do this, again, it's going to be easier to show you some examples and kind of walk you through how to do it. And I've got a bunch of problems here on these next few slides. I don't know that we'll do every problem, but I want to do several because it's just a matter of knowing the steps and just following that over and over again. So we're going to start with this problem. And the way this is going to work is because this first number is not 1, we're going to take it and multiply it by the last number. Now, when we do, we are removing the 3 completely, and it's going to leave us with x squared. And we're going to have plus 7x. And then that 3 gets multiplied by the 2, and we get 6. The whole purpose is so that we do get a leading coefficient of 1. Now we'll factor that using reverse FOIL. Again, see the previous videos if you're not sure how to do that. And so our first term is x, and we're looking for two numbers that will multiply to give 6 and add to give 7, which is 6 and 1. And then our signs are the same because, again, this sign is positive. And they're both going to get this sign, so both positives. But here's the problem. You'll notice that when we multiply these two binomials together, we do not get what we started with. We get this, but we need to be able to get what we started with. And so the way that works is because we multiplied by 3, we have to divide that 3 back out. And so both of these numbers will get divided by 3. And so then we'll simplify those fractions. So 6 divided by 3 is 2. So if your fraction simplifies, make sure you simplify it. If it does not simplify, like with the 1/3, that 3 is going to get moved from the bottom of the fraction up in front of the variable. That's why I call it bottoms up. And so it becomes 3x plus 1. And there's your final answer. Okay. Again, you can check that if you want to multiply. You could multiply it together and see that you do get what you started with. If you will follow this process, and it's really multiplying the leading coefficient by the last number, factoring it, and then dividing it back out. That's really all there is to it. Some of them get a little bit longer than this. If the fractions will simplify, but they're still not whole numbers or things of that sort, which you'll see in a few minutes. But it's really that process. And if you'll follow this process, it's going to work every single time. Okay? So let's try a few more. On this next one, I'm going to zoom it in just so I have some room here to work. So our leading coefficient again is 6. And notice that in these we don't have a greatest common factor. We're going to check for that and make sure. Sometimes you do have a common factor, sometimes you don't. In this case, we don't have a common factor. Nothing goes into 6, 19, and 10. So we can see quickly there's not a common factor. So we're going to take the 6 and we're going to multiply it by the 10. And again, that's going to leave us with k squared minus 19k plus now 60. Now, where this can get a little more complicated is as this last number, this constant number, gets bigger, it be a little more complicated maybe to know what multiplies to give that number and adds to give the middle number or subtracts to give the middle number. And so that can be a little bit of a process. And so you just have to think about, well, what multiplies to give 60? And think about all the possibilities. And usually there's going to be something that works. So in this case, we're going to continue to factor with k being our first term. And we are looking for two numbers that multiply to give 60 that will add to give 19. Now, as a side note, if you were to take that 60 and you say, well, I don't know all the factors, break it down into its prime factors. So you may say, well, that's 6 times 10, and 6 is 2 times 3, and 10 is 2 times 5. And some combination of these four numbers multiplied together would give us what we're looking for. And so in this case, if the numbers need to add to give 19, they have to be both of them have to be less than 19, so they can add to give that. And so we know 6 and 10 don't work because 6 and 10 is 16 if you add those. So what I think about here, quit doing that. What I think about here is if I could take this 2 times 2, that's 4, and 3 times 5, well, that's 15, and 15 plus 4 is going to be the 19. So that's going to be my two numbers that I need. If that didn't work, I would try something else. Maybe I would do 2 times 3 times 2, and then times 5. And so you can, again, play around with this to figure out those numbers that work. But some combination of 2 times 3 times 2 times 5 has to work. Okay, so in this case, 15 and 4 are the numbers that we need. Again, signs are going to be the same, both negative. And then we're going to divide by 6. Now, notice here when we divide by 6, neither of those fractions will simplify to a whole number, but they both simplify. And so we need to simplify them. And so the 15 over 6, 3 goes into both of those. It simplifies to 5 over 2. And the 4 over 6 simplifies to 2/3. And now we're going to move our denominators up. So the 2 gets moved up, and the 3 gets moved up. Again, we call it bottoms up because it moves from the bottom up in front of that variable. And so this is going to leave us then with 2k minus 5 times 3k minus 2. And there's our final answer. Now, the problem that I see people make a lot of times here is they will get started in this and they say, oh, well, I know it's got to be 2k and 3k, and they know it's got to be 5 and 2, and they end up just kind of doing a guess and check, and when they do, they end up having the 5 and 3k grouped together and the 2k and the negative 2, and that's not going to work. You have to have the right binomials together. So for example, if you did 2k minus 2, well, that's not going to work. It's not going to multiply together to give you what you started with. This is the only answer that is possible. Okay, so if you have anything else, it's wrong. So just be aware of that. Now, continue on and look at the next problem. Again, if you have questions about any of these, let me know. Hopefully as we do more of these, it'll become more clear what we're doing each time. Again, steps are pretty much going to stay the same. Now, you'll notice that in this one, again, we don't have a greatest common factor. Still look for that every time. In this case, we don't have one. So we're going to take the 8. We're going to multiply by the negative 3. And it's going to leave us with y squared minus 10y minus 24. And then we're going to factor that. So y is the first term. We're looking for two numbers that multiply to give 24, that subtract to give 10. Now, some of you may be tempted to say 6 and 4. Because 6 and 4 multiply to give 24 and they add to give 10. But this says they need to subtract. This sign tells us they need to subtract to give 10. Well, 12 and 2 subtract to give 10, and they also multiply to give 24. So again, you've seen a couple combinations already in the other videos of numbers that multiply to give the last number and add to give the middle number, or also subtract to give the middle number. And so you've got to be careful on which one you choose. It's all based on that last sign. In this case, it tells us they need to subtract to give 10. And so then we can put our signs in. So again, because this sign is subtraction, it tells us the signs are different. This one goes to the biggest number. So the 12 is negative, the 2 must be positive. And then again, we're going to divide by 8. We multiplied by 8, so we divide by 8. And again, you'll notice that these fractions do simplify, but not to whole numbers. So 4 goes into 12 and 8. It simplifies down to 3 over 2. And 2 over 8 simplifies to 1/4. And then you'll move your denominators up. And so the 2 gets moved up and the 4 gets moved up. So our final answer then is 2y minus 3 and 4y plus 1. And so now we have that trinomial factored. Again, if you have any questions about that, let me know. If there's anything I need to go back over with you, I'll be glad to do so. Alright, so let's look at the next one. So this one at the top is very similar to this one. Same numbers and everything, it's just that we end up with a difference of signs. So I'm going to skip that one. If you want to do that one, you can do that one on your own. Again, you're going to have the same exact binomials, but your signs are going to be different. Here you had both signs negative. On this one, both signs are going to be positive. That's the only difference. So if you want to work that one, you can. You'll have the P instead of a K, obviously. And both signs should be the same. So if you want to do that one, you can try that one on your own. I do want us to look at the last one, though. So notice here that, again, we don't have a greatest common factor. Nothing goes into 10, 23, and 12. And so we're, again, going to multiply the 10 times 12. And we're going to get m squared minus 23m plus 120. And again, some of you may look at that 120 and go, well, I don't know. I don't know what multiplies to give that and adds to give 23. Well, again, just make a little side note here. Take the 120, break it down into its prime factors. Well, we know it's 12 times 10. That's what you had to multiply to get it. 12 is 4 times 3. 10 is 5 times 2. And 4 is 2 times 2. And so you just break all these down into their prime factors. And then some combination of these numbers will add, or should add, to give 23. When you use all of those, they multiply to give 120. That's for sure. Okay? So, first thing maybe you look at as well, 10 and 12. Well, that's 22, not 23 when you add those. You know that because the numbers need to add to give 23, you can't have anything bigger than 23. So, for example, you couldn't have 2 times 60. right? Because 60 is bigger than 23. It's not going to add to give 23. You also couldn't do 3 times 40 because 40 is bigger than 23. So you can narrow down some of your numbers that you're looking for. So when I look at this, what I notice is that, well, if I did 2 times 2 times 3, well, that's my 12 times 10. Again, we've already said that's not going to work. Okay? So let me zoom this back out so I can erase that. So we could then say, well, 2 times 2 times 2, that's 8. And then 5 times 3, that's 15. And 15 plus 8 is going to be that 23 I need in the middle. And so that should be my 2 numbers that work. Okay? And so we'll again factor this with m being our first term. Our 2 numbers that multiply to give 120 and add to give 23 will be 15 and 8. Signs are the same, both going to be negative. And then we need to divide by the 10. And so when we divide, 15 over 10 simplifies to 3 over 2. The 8 over 10 simplifies to 4 over 5. And then we're going to take those denominators and move them up. And so our final answer is 2m minus 3 times 5m minus 4. And again, there's your final answer. If you have any questions about that, let me know. We've got a few others we're going to do, but that is what this section's all about. Okay, so being able to do that bottoms up method. Again, this is a method that you'll have to know. You have to know how to do reverse FOIL, but you also have to know how to do this one in case our leading coefficient is not 1. Okay? If there's any questions, again, let me know. All right, so let's continue on. I believe we've got 8 more. We're not going to do all 8 of these just for the sake of time. But I do want to kind of be strategic here. So let's start with the first one. We may do all 4 of these just because they're all a little different. So again, let me zoom this in. So you'll notice here that we still don't have a common factor. 6, 11, and 10 don't have a common factor. There's not an m in every term or an n in every term. And so again, no common factor. So we do want to take the 6 and multiply by 10. And we're going to have m squared plus 11mn minus 60n squared. And so then we'll factor that. And you'll remember from section 6.2, our first term has to have m, but our last term has to have an n. Because again, there's 2 variables here, and n times n is going to give us that n squared at the end. Again, we addressed this in the previous video in section 6.2. Now, we're looking for 2 numbers that multiply to give 60 that will subtract to give 11. Well, this time, because they need to subtract to give 11, one of the numbers has to be bigger than 11. And so the first thing I think about is one that we used in the first problem, or maybe the second problem we did a few minutes ago, 15 and 4. Right? 15 and 4 multiply to give 60. 15 minus 4 is 11. So 15 and 4, again, are the numbers we're going to use. The signs are different, again, because of this negative sign here. Biggest number gets the positive, so the 15 is positive. The 4 must be negative. And then we'll divide by 6. And both fractions, again, do simplify. So 15 over 6, 3 goes into both of those. Simplifies down to 5 over 2. And don't forget your n. And then the 4 over 6 also simplifies to 2/3. Again, don't forget your n. And now we can move our denominators up. So the 2 gets moved up, the 3 gets moved up, and we end up with 2m plus 5n times 3m minus 2n. And so there is our final answer. Hopefully not a lot to that. You should be able to do that hopefully on your own. Again, if you have any questions about that, let me know. I'll be glad to answer any questions you have. Now, look at the next one. There is a typo here. This should be an r squared at the end. Okay, so be aware of that. Now, this time we do have a common factor. Number one, there's a number that goes between, that will go evenly into 28, 58, and 30. 2 does that because, again, they're all even. And then they all have r squared. And so our greatest common factor here is 2r squared. And so we need to factor it out. And when you factor that out, you're going to divide that 2 out of every term. And so 28 divided by 2 is going to be 14r squared. 58 divided by 2 is going to be 29r. And 30 divided by 2 is 15. Again, remember we're subtracting the exponents on the r's. Well, it's been factored, but it's not factored completely because this trinomial can still be factored. And so we're going to bring down the 2r squared. And then we're going to factor, well, before we factor, we're going to do bottoms up and multiply 14 times 15. Again, you can do that out to the side if you need to. You should get 210. So just bring everything else down and then minus 210. Again, the 2r squared is part of the answer. We'll just keep bringing it down. And now we can factor that trinomial with reverse FOIL. Oh, sorry. And so we'll have r as the first term. And now we're looking for two numbers that multiply to give 210 that subtract to give 29. Well, you might be tempted to try 14 and 15 because they add to give 29 and obviously multiply to give 210. However, the numbers need to subtract. Again, this last sign says they need to subtract to give 29. So one of the numbers has to be bigger than 29. Okay? So, again, out to the side, I would do a little factor tree. We know 210 is 21 times 10. And 21 is 7 times 3. 10 is 5 times 2. And so some combination of these numbers multiplied together are going to give us that 210. And since one of the numbers has to be bigger than 29 so that it can subtract down to 29, start thinking about what your options are. Well, the first thing I see is that if I can multiply 7 times 5, that's 35. It's bigger than 29. And 3 times 2 is 6. Well, 35 minus 6, that is the 29. That's what I need, right? And so 35 and 6 are those two numbers. Now, again, signs are different. Biggest number gets the negative. And then we multiplied by 14, so we got to divide by 14. And so, again, we'll bring down the 2r squared. The 35 over 14, 7 goes into both of those. We get 5 over 2. And then the 6 over 14, 2 goes into each of those. We get 3 over 7. And then we're ready to move our denominators up. So the 2 gets moved up and the 7 gets moved up. And we get 2r minus 5 times 7r plus 3. And again, what you'll notice here is that when you multiply the binomials together, you get this trinomial. And then when you distribute the 2r squared, you get the original trinomial that we started with. Again, if you have questions about that, let me know. This is as long as this problem could get, where you take out a common factor, you go through the bottoms up process, you simplify your fractions, you still got to move something up. It does not get longer than this. And some of you may say, oh, that's too long, I can't do it. Okay? You need to get so good at this that you don't think about it being more than just a few steps, because when you get into college algebra, this is a very small part of bigger problems. And you may have problems where you do this multiple times. And so within one problem. And so you've got to get pretty good at this. Again, guess and check takes a lot longer. Even though you may say, oh, I could have figured that out. Well, maybe. But odds are you would have taken you a while to guess and check and figure out what numbers to use. And so I definitely encourage that you use this method, even though it is a few steps. If you can do this, it works every time. And then again, in college algebra, you can just click along pretty easily after that. Okay? If there's any questions, again, please let me know. So what I would like you to do is to try this one on your own. So I give you 3 seconds to pause the video. Alright, so if you do this one of the things that I would encourage you is to make sure you factor out your common factor with the negative. Take the negative out, because we don't want this first number to be a negative. If you go back into section 6.2 and everything we've done here in section 6.4, this first number has always been positive. And so we really would like to keep it positive. You can do bottoms up with a negative, but there's some sign issues that you could get into, and I really don't think it's worth the hassle of trying to figure out, okay, what are my signs supposed to be? If I can go ahead and factor the negative out, then my signs are going to work out perfectly. So in this one, we do have a greatest common factor. There is a number that divides evenly into 24, 32, and 6. And you probably look at that, and some of you are going to say 6, and some of you are going to say 4, and some of you are going to say 2. 2 is the right number. 4 does not go into 6, so that can't work. 6 doesn't go into 32, so that can't work. So it is 2 as far as the number goes. So our greatest common factor is going to be a negative 2x. Again, we want to factor the negative out because the first sign is negative. And there's an x in every term. There's not a y in every term, just an x in every term. So when you factor out the negative 2x, we're going to be left with 12x squared. It is a positive because it was negative 24 divided by negative 2, which is positive 12. Minus 16xy. So 32 divided by negative 2 is negative 16. And then 6 divided by negative 2 is negative 3 with the y squared. Now, again, we've got our common factor. We're just going to keep bringing it down. It's part of the answer. And then we're going to do bottoms up. So we're going to multiply the 12 times the 3. It's going to leave us with x squared minus 16xy minus 36y squared. So, factor this now. So first term is x. Second term has the y in it. And then we're looking for two numbers that multiply to give 36 that will subtract to give 16. Well, again, because the numbers need to subtract to give 16, one of the numbers has to be bigger than 16. And so hopefully you know that 18 times 2, jumped on me. 18 times 2 are those two numbers. Again, signs are different. Biggest number gets the negative. It won't cooperate. There we go. So the negative 18, positive 2. And then, again, bringing down that, tell you what, let me do this. Let's got me all messed up jumping around like it was. Alright, so now that we've got it factored, we multiplied by 12, we got to divide by that 12. And so you'll divide by 12 here and there. And then we'll bring down the negative 2x. We'll simplify each fraction. So 6 goes into 18 and 12. Simplifies to 3 over 2y. And then the 2 over 12 simplifies to 1 over 6y. And then we're going to take the 2 and move it up. And the 6 and move it up. And so we have negative 2x times 2x minus 3y times 6x plus y. Now you can put 1y if you want to, if that makes you feel better, but the 1 with the y is not required. And so if there weren't a y, you'd have to put the 1. But in this case, because you do have the y, you don't have to put the 1, so I typically would leave it off. Again, if you have any questions about that, let me know. Again, that's as long as it could get. Taking out your common factor, doing bottoms up, when you divide, simplifying your fractions, and so on. Not anything else really to that, other than just trying to practice some other problems. So we're actually going to skip the next problem because it's very similar, where you would take out a greatest common factor with the negative. So just for the sake of time, I'm not going to do that one. If you have any questions about it, if you want to try it, email me and ask me about it. I'll be glad to kind of walk you through that. And then on this next slide, really the same thing in each of these. The one thing I'll point out to you is that in this one, okay, the top one on the right here, there's not a greatest common factor other than negative 1. So you want to make sure you factor out a negative 1 and get 2p squared plus 5p minus 12. And the reason we want to do that, again, is because we don't want to have to worry about dealing with a negative when we divide. And so then you can do bottoms up, and you're just going to have this negative 1 that kind of follows you into the answer. So your answer is going to be negative 1 times whatever that trinomial factors into. Okay, so you can look at all of these. You could try every one of these yourself. Again, if you want to try some of these, email me. I'll be glad to tell you if you got it right or wrong and try to walk you through any mistakes that you made. I feel like if you can do those first ones that we've already done, then you should be able to do these. So that does finish up section 6.4. In our next video, we'll be into section 6.5, which I believe is our last section of this class. So be looking for that video. It will be